Systems of equations. So this is a review of Algebra 1. You did graphing substitution and elimination there. Here we go. Y equals 3/4 x minus 4. That'll be the first equation. And the second equation, y equals a negative 1/2 x plus 1. And what we want to do is find out where these two equations hit each other, where these two lines, this is y equals mx plus b, this is y equals mx plus b, where they hit each other. So this graph right here will have a y-intercept of negative 4, 1, 2, 3, 4, and I go up 3 over 4, up 3 over 4. I'll take a straight edge and graph my line. Then the second equation. There's equation 1. Here's equation 2. Y equals a negative 1/2 x plus 1. There's my y-intercept of 1, and I'll drop down over 2, drop down over, boom, there it is, drop down 1 over 2, and I can see where they hit each other, but I'll still go ahead and graph this out. It's important that you understand that there are many lines, many points on the blue line. Here's one, here's one, here's one. And there are many points on the purple line. But there's only one point that exists that is on both the purple and the blue line. So that's this point right here. Now, not all lines hit each other. It would be possible for us to have two lines that have the same slope, which you know are parallel, and then they would not hit. This is the graphing method. It's not the best method because it doesn't always turn out to hit at a nice lattice point. Now, the first problems that we work will turn out to hit at a nice point, but then as we go on further and further, the graphing method will not be the best method because they won't hit at just that one point. Method number 2, substitution. Y equals 3/4 x minus 4. And equation 2, y equals a negative 1/2 x plus 1. There's equation 2. There's equation 1. With substitution, what we want to do is get one variable by itself in one of the equations. Now, in this case, the y is by itself in the purple equation. It's also by itself in the blue equation. If this was given to us in a different form, we might have to get it by itself by rearranging the equation. Once I have the variable by itself, though, I simply take what y equals and I plug it into the other equation. So in equation number 2, I no longer will write y, but I will write 3/4 x minus 4 equals a negative 1/2 x plus 1. Now, I could solve this equation in dealing with the fractions, but I think I would rather get rid of them. So I'm going to multiply everything by what the denominators go into. 4 and 2 both go into 2. I'll multiply everything by 4. 4 times 3/4, the 4's reduce, and just leave me with 3x. 4 times a negative 4, negative 16. 4 times a negative 1/2, negative 2. 4 times 1, 4. Now, a mistake people make when they're doing this is they multiply everything but maybe the 1, and then you get the wrong answer. You have to make sure that you multiply each term if you're going to do that. Now, this is an equation we can solve. I'm going to add 2x to this side and this side. 5x minus 16 equals 4. Add 16 to both sides, and I get 5x equals 20. Dividing by 5, x must be 4. Now that I know what x is, I can choose any place at all that I can find to plug x back in and find out what y is. I guess I'll choose the top equation. Could have chose the bottom one. But in the top equation, it says y equals 3/4. I know now, though, that x is 4 when they hit, when the two lines hit each other, minus 4. The 4's cancel, so y equals 3 minus 4, negative 1. So the point, 4, negative 1. Just like the point up here, 4, negative 1. Of course, if we do something a different way, we should still get the same answer. The next method is the elimination method. Here's equation 1, y equals 3/4 x minus 4. And equation 2, y equals a negative 1/2 x plus 1. With the elimination method, what we want to do is, it is best to get both equations in standard form. And that will help us later when we solve these by a fourth way, matrices. So far we know graphing, substitution, elimination. There will be a fourth way, matrices. But before we do this with elimination, I'm going to change it into standard form. First, I multiply equation number 1 times 4. That gives me 4y equals 3x minus 16. Each term got multiplied times 4. Equation number 2, I want to clear its fraction out, so I'm going to multiply times 2. That gives me 2y equals a negative x plus 2. Each term got multiplied times 2. So I'm going to rewrite equation 1 and equation 2 in standard form, and I'm not quite there because I don't have the x's and the y's on the same side of the equation. When I move the x over, it becomes negative 3x plus 4y equals a negative 16. And in the blue equation, when I add x to both sides, I get x plus 2y equals 2. So this is number 1, equation 1, in standard form, and equation number 2 in standard form. Now, to be perfectly honest, you don't have to have them in standard form. But again, that will help us later on, so we might as well do that. The process of elimination means we're going to try to eliminate a variable. I can either get rid of the x's or the y's. It does not matter which one you choose. If I choose to get rid of the x's, when I'm going to add the equations together, when I have a negative 3x, I'll need for this to be a positive 3x so that they'll cancel. Or I could multiply this by negative 2, and then I would have 4y and negative 4y. And when I added them together, they will cancel. Well, I guess I have to choose one. So I'll choose equation 2, and I'm going to say that I'm going to multiply everything in equation number 2 times 3. Doing that, I get equation number 2 becomes, when I multiply by 3, 3x plus 6y equals 6. I'll rewrite equation number 1 above it. I'm going to add the equations together. Negative 3x plus 3x, gone. 4y plus 4y, that is 10y's. And a negative 16 plus 6 gives me a negative 10. Dividing, I get y equals a negative 1. Just like we did before. So now that I know that y equals a negative 1, I can plug that back in. Sometimes with this method, there are not good places to plug it back into. If you started with a standard form equation, plugging it back into that, you have to manipulate a little. But we started with slope-intercept form, so we can just take this y and plug it in and solve for x. Now if I do that here, though, I have fractions. So maybe it would be better to plug it into either the purple equation here or the blue equation here. You can do any of this. I'm going to plug it into this blue equation here because I have the blue pen in my hand. So when I plug it in right there, I get 2. I will not write y because now I know what y equals. Negative 1 equals a negative x plus 2. So I get a negative 2 equals a negative x plus 2. And if I subtract 2 from each side, subtract 2 over here, it becomes 0. Subtract 2 over here, I get a negative 4 equals a negative x. Dividing by a negative 1, x equals 4. So again, I get the point 4 comma negative 1. Now in this problem we worked it 3 different ways, so I would not expect you to check it. 4 negative 1, 4 negative 1, 4 negative 1. We assume that we did a good job on this. But if I only had you solve this one way, then it's important for you to understand that you should check your work. If you plug 4 back in to the original equation, when I put 4 in, the y value better be negative 1. And when I put 4 in to the second equation, the y value better be negative 1. If it does not work when you plug it back into both equations, you have the wrong point. On the back side, there's a problem for you to practice 3 ways. And I'd like for you to graph y equals a negative 3 halves x plus 2 and y equals x minus 3. Then solve by substitution, then solve by elimination. And we'll practice more in class.